Hello, and welcome to the Kansas City SQL Server User Group. Happy to have you. And tonight we have Mahadevan presenting Finding and Fixing T-SQL Anti-Patterns with ScriptDOM. For the audience, this session is recorded and will be uploaded to our YouTube channel in the next few days, and I will place the link inside our meetup event. For Q&As, we will have live throughout the session, so feel free to ask. I will monitor those and then give them to Mala. And with that, I'm going to hand this over to you, Mala.
Thank you, Christy. Hello, everyone, and thank you for taking time to attend my talk this evening. I'm going to be speaking to you on finding T-SQL anti-patterns with a little-known tool called ScriptDOM. This is a little bit about me. I live out here in Raleigh, North Carolina, and I'm a co-lead for two user groups, the Data Platform Women in Tech user group and also the local TriPass SQL Server user group. I have a blog site at Curious About Data, and I'm on Twitter as SQLML. I don't know how many people are on Twitter nowadays, but whatever, maybe it's time to update this. Okay, the takeaways for today. We are going to understand what is this tool and why is it particularly useful. Simple PowerShell-based scripts using this tool to identify some anti-patterns, fix some of those anti-patterns, and learn the pros and cons of this tool. That's essentially what about 50% of my talk is going to be the theory around what this tool is and how it is structured and so on. There is no real way out of that because you have to understand how it works to put it to good use. Otherwise, it's going to be pretty difficult to get your head around. The rest of it would be code-based demos. Okay, let's start with what exactly do we mean by anti-patterns. Anti-patterns are essentially techniques that evolved to solve a problem, but then over time it has been used too much and it leads to other problems. Anti-patterns are pretty common. They are practiced by a lot of people. Like I said, they evolved for a reason, so they have some legitimate uses. These are examples of some anti-patterns that we have in the T-SQL world. You may notice that most of us will have one or more of these in our environment. In addition to things like this, anti-patterns also include specific things that are very custom, very specific to your environment. Like, for example, in my environment, we use Query Store, a lot of Query Store. And Query Store has a problem with temp tables that do not have specific names. That is, they have default naming. So when you use temp tables like that and you force a plan, it is not able to find the plan the next time. So in my environment, we have an anti-pattern that all temp tables should have named keys on them. Now, nothing's going to happen if you have a temp table with an unnamed key other than this Query Store issue. But we have a rule like that suits our environment. So like that, you may have rules that are peculiar to where you work. Sometimes naming standards and formatting standards are also part of this thing. So your list of anti-patterns may be a little bit different than mine, although there may be common things like nolock hint, I would think should be on everybody's anti-pattern list. The rest of it is dependent on your environment and what you're managing. So these are some common examples that we call anti-patterns. Okay, now what are the options available if you need an automated way of finding some of these anti-patterns in your code? What are some of the places you look for? There are some options. One is text-based search. The other one is regex. The third is third-party tools. And the last is the one I'm talking about. So we'll look at the pros and cons of each of these things. The first one is a text-based search. The text-based search, the biggest problem is false positives and incomplete details. So if somebody has written a comment that, I inserted nolock here for this reason, blah, and a date, it's going to pull that up as something that is existent, although, maybe that nolock was removed some days ago, but it's not going to be able to differentiate between something that is a comment and something that is in code. So this is what we call a false positive when you do a text-based search. And also the details you get with a text-based search are going to be incomplete, right? Where in the code is that occurrence, what line, what column, this sort of stuff. So text-based search is very limited in this regard. Regex. Now everybody knows, everybody who's used regex knows it's fairly complex to construct, and you need multiple constructs to find multiple types of situations. So that is not an ideal way to go about looking for anti-patterns. Third-party tools. There are lots and lots of third-party tools available. If you go and look on GitHub, you can see plenty of things that people have written and put out there. The problem with third-party tools is that they are unsuitable for specific needs. Like I said, every person's list of anti-patterns varies depending on where you work and what your environment considers suitable. So you need to make changes to whatever somebody has written. It needs upkeep. So that is an additional overhead when you use third-party tools. DMVs. A lot of people have used DMVs historically. The problem with DMVs is somewhat similar as text for code, is that it's going to find it on a text-based search basis. If you use that DMV to search in stored procedures and such, that's what it's going to find. So again, false positives and incomplete details. And the problem with DMVs also is that it can only find issues after the object is created, after you hit the server. If you have a good CI/CD process, you should be able to filter out some of these anti-patterns before that code hits your server, before the developer or whoever is writing it has implemented it. You should be able to say, this is a no, you need to go and fix it before we deploy this on production. So that sort of a thing is not possible when you use DMVs. Clearly, because it can only find it after the code has been deployed. So let's look at how ScriptDOM is advantageous over these approaches. One is that it can find problems before the objects are created or before that code is deployed, which is a good practice when you have a large code base. It is a scientific method that is more reliable. It will not give you false positives. It will not find hints that are in comments or things like that that are not actually code. And then it is version compatible. So you have a different version for each SQL Server version that comes out. So it is not going to have problems with finding whether or not what it's finding is still a problem in the current version of SQL Server or not. So it's version compatible. These are the advantages. So let's go into understanding what exactly is ScriptDOM. ScriptDOM is short for T-SQL Script Document Object Model. And it used to be part of the .NET Framework library from a long time ago. It has existed since the days of SQL Server 2008. It is part of the DACFX package. Fairly recently, up until SQL Server 2019, it was part of the DACFX package. And when you install DACFX, it used to come along with it. Sorry, I went too fast. Currently, it comes along with the SQL Server install. So if you go and look on a certain directory after you install SQL Server, you can find it. You can still find it as part of the DACFX package also. So what can it do? What can it do? It can do all these things. It can parse T-SQL scripts and find any parsing errors, that any syntax errors or anything like that you have. It can format T-SQL scripts according to some very generic standards, and I'll show you examples of these things too. It can find anti-patterns, which is arguably the best use of it. It can find anti-patterns in a scientific way for you. It also has the capability to fix some of these anti-patterns. There are pros and cons to this. I'm personally not a fan of tools that automatically make changes to your code, because as a developer, you're not going to know that you made a mistake. But it has the ability to fix some of these anti-patterns if you are in a position where you have to do that. So we'll see how that works too as part of this. So when is this kind of tool most useful? This is useful when you have a very large T-SQL code base and you have a bunch of legacy code, that is different versions of SQL Server and such, and you want to find issues before they get deployed, not after they hit the code base. This is the ideal scenario where you want to put ScriptDOM to use. Although theoretically you can use it in any scenario. You can use it for small code bases, you can use it for any version of SQL Server, but there is some effort involved in getting it to work. There is some effort involved in writing the scripts that are peculiar to your list of anti-patterns. That's why I have this listed, that that effort may be justified if you have these things, that if you have a large T-SQL code base, if you have a lot of legacy code and you want to find issues before they're deployed. And not all of these conditions need to be true. Any one is okay. if you have any one of these issues, you can talk to whoever your manager and find time to get this done, and you may find it useful, very useful. And lastly, you do not want any more stress on servers finding anti-patterns. This tool is asynchronous. It does not need a SQL Server connection to run. It can run on your text files, your code files. So you do not want to stress your server at all finding these anti-patterns, and you can do that completely offline asynchronously. Installing ScriptDOM. Installing ScriptDOM is you can download and install SQL package. Like I said, the DACFX package that is currently the method 2, although it comes along with SQL Server 22.2. I haven't personally researched to see where the exact location they put this DLL in along with SQL Server 2022, but that's what I'm told. But this old method also, it definitely works. That is, if you install the DACFX package, it comes along with it. There are separate versions for .NET Core and .NET Framework. The version I'm going to be demoing to you today is the one for .NET Framework. And then all you need out of the install is just one library, one file, one DLL that is named like that. So that's literally all it needs. It has no other dependencies to work. You can go to the appropriate location on your SQL Server, whichever version you're using, and look for it like that, and it will find that DLL for you. That's all you need. So no SQL Server install is necessary. Okay, now let's look at the structure of this library a little bit before I show you how it's going to work. Now, the important classes is that it is a pretty big namespace, and some of this is .NET terminology, so I ask pardon to those of you who are not familiar with that, but it's really difficult for me to get into how, all the explanation of all of that in 1 hour. So if you don't understand, then I ask pardon. It's actually really simple, but it carries a lot of jargon, so it can seem daunting to some people. It was to me initially. This is the namespace, that big thing you have there. That is the ScriptDOM namespace, and it has about more than 1,000 classes. So it's a pretty big object model. Essentially, think of it as an object model with a lot of classes. So it has more than 1,000 classes. And there is a different parser for each version of SQL Server. Now it is 180 for SQL 2022. When I wrote this presentation, it was 170. So, but from all the way from SQL Server 2008, which is T-SQL 80 to 170, there is a different parser for each version. There is also what they call a T-SQL fragment class. A fragment class is what creates the syntax tree that is used to do this, whatever it has to do. So that is an important class. And there is also what they call a visitor class. A visitor class is something called a visitor pattern implementation, and I'll explain what this is to in a second. So these are the, in addition to these classes, there is also a script generator. A script generator is the one you use if you have to reformat your code, or if you have to use this tool to fix the patterns automatically. So that is also, like I said, that is a different version. They started doing it from 110. So from 110 to 180, that is 2022, there is a different version for each version of SQL Server. And there is also individual language-based. T-SQL is a very wide language. So for each element of this language, there is a class. So for example, name table reference is a class, select star expression is a class, and on and on and on. There are thousands of classes, and I'll be demonstrating to you how all this works. But this is essentially the structure of the library, and a basic understanding of this is enough for anyone to put it to use. You don't have to get into a lot of detail. So let me demo the parser for you. Okay, I will show you what the code is like and then demo it. So this is just a stored procedure that I have, and then what I'm doing here is that I'm initiating the library first. That is, I'm telling the code that this is where the ScriptDOM library is, and then I'm making sure I get the assembly version and everything, making sure I have the right version or the wrong version. That this is just precautionary on my end, and then I'm trying to parse. Okay, the parser, I create a new object out of the parser. This is what I told you is a different version of each version of SQL Server. And then I create an error object in case there are any parsing errors. And then I read whatever script I pass to it. Now, for the sake of demo, I have put the stored procedure into a variable here. You can absolutely put it into a file and pass the file to. That's a normal way it is done in the real world, but this is just for a demo, so I used a variable here. So if you have work with a file too, and then the parser creates objects. It tries to parse it and creates an output. If there are no errors, it's going to tell you there are no errors. If there are errors, it's going to throw the errors. So I'm going to stick some errors in this code. Let's say I add an E with the declare. I just, just a typo, and I want to check if this is fine. So I run it. So it's going to tell you that it found an error near that. So it's going to find syntax errors like that. And if you remove this and run the same thing, no parsing errors. So all it's doing here is a syntax check, and this is the same library, the same thing that is invoked in SSMS when you click that green arrow button and let you want to parse your code. That's what they're doing behind the scenes. So this is what we do manually. We are invoking the library on our own. And this is not going to validate if your table names and your column names are valid and such, because it has no connection to any SQL server. So that's not going to get validated. All it's validating here is your syntax. If your syntax is okay and if your code is parsable. The same thing that happens on SSMS when you click that green arrow. So that's what it is. I thought I had the presentation. Okay, saw the demo here. All right. So what are the components of parsing? We just saw what parsing involved. So how it works is that this is essentially the text that you sent. This text goes to what is first called a lexer. So anybody has been to computer science class in school, these terms would be familiar to you. Terms like lexer and tokens and all that. So this is just the same concept. The lexer is what creates tokens from script. Tokens are essentially every word, every syllable that is part of that text file that you send, that makes up a token. So I'll show you what tokens are in a demo. For now, you understand. If you say select star from table A, then select is a token, space is a token, star is a token, again space is a token, and the table name. So that kind of splitting the code out into tokens. These tokens are then sent to the parser. The parser then outputs what is called an abstract syntax tree. The parser matches these tokens to inbuilt rules like SQL Server rules on syntax. This is what you always have to say select star from something, and if you leave out the from, that's a syntax error. So these tokens are matched to those internal errors, internal structure in the parser, and then if your code is free of syntax errors, it outputs what is called an abstract syntax tree. That is a tree-like construction of your code. And then it evaluates if this syntax is all correct. And if this is correct, then it says, okay, you're good, just like we saw, no parsing errors. And this output, whatever it has here, is what we use to find out if the code has any anti-patterns. So this is basically how it works. It's fairly simple, but you really have to understand things like what are tokens and what is the abstract syntax tree, what it outputs out of this. What exactly do we mean by an abstract syntax tree? Abstract syntax tree is a tree-like representation of the syntax with each node of the tree denoting a construct, and it's the output of the parser object that we saw. So if you have a T-SQL statement like this, say, this statement has various things as part of it. It has a grant, it has a revoke, it has, various things, import, export statement, create, alter, drop. It could have any of this. So what this abstract syntax tree does is to construct it in the order you have written the code. It's going to make a tree-like structure based on all the things that it finds in the code and come up with something like this. So this is what is called the abstract syntax tree, and this is the output of the parser. So why do you need this abstract syntax tree? This is a fairly simple example that many people would have seen. This is to add context. Okay, a panda eats shoots and leaves, but if you add the Oxford comma there, you understand what it really means. Eats, shoots, and leaves as three different verbs. So this is the kind of thing that you need an abstract syntax tree for versus a text-based search. That is, you find things in the right context. What the tree does is to add the context that the Oxford comma added in this case. That's why you really need it. Although it may be complex and difficult to understand, the way that this thing differentiates between something that is in text and something that is an actual logistic part of your syntax is by constructing that tree. And that tree serves the same purpose that the comma does in this example. So let's explore what this abstract syntax tree looks like and also tokens and how they work. Am I making sense so far, Krista? Okay. So okay, this is basically the same thing. I have a big select statement. I use wide world importers, and what I have is a big select statement. I'm doing the same thing that I showed you before. A little bit of difference is that after doing this parsed objects, because my code is free of syntax errors, I'm walking the tree statement by statement. That is for each statement, and I'm finding what is the statement type. That is just like I showed you in on the slide there. Like you initially you have a use statement and then a go and then a select statement and such. So that order, and then stuff like this. So we'll see. One second. Okay, so now I'm going to show you how this thing looks like. Okay, so this what you see here is the tree that it has constructed for you. So it has select elements. It's not telling you what those elements are because there are lots of elements here on that select statement, and we can see what they are one by one. The from clause, the where clause, the group by clause, there is nothing, there is no group by in my select, so there is nothing here, and on and on and on. Okay, this is and this is what I call tokens, and we'll see what tokens are later. But this is how the tree looks like, that it is split your select statement into parts and put it stuck into different parts of this object model. And you can walk the tree and you can see further, like for example, I want to see what your select elements are. So each the screen is not very clear, but okay. So column reference expression, and then what line and column the column is and all that stuff. So each expression is the one column or one element that you're selecting. That's how it is selected. We can see one by one. This is the first one. This is very array heavy, so you have to provide the array element. The first column is the one that is 0. That's the column reference expression. Dot expression. Column type regular, multi-part identifier, and all that stuff it has. So you can go down on and on. You can go down to the tree to whatever level you want to get the level of detail that you need. Value is P. You can see what is P here. P, it's referring to this alias. person ID is the name of the column, and so on. So this is how it stores what you want, and you can see how deep it is, because even this is just one select statement, and even for this you have so many layers to go before you can unwrap what the whole statement is about. So this tree can get pretty big if you have a stored procedure, or if you have something, a lot of code. Okay, now I show you what tokens are. Now I have a very simple statement here: select star from my table. And I'm going to run this to see how this thing splits this thing into tokens. So when I do this, what it's doing is that it's telling you starting from the first thing is saying a type is a single line comment. It's referring to what I have here, -- testing tokens. It's a single line comment. Location is line 0, column 1. It's not a reserved word. Okay, and then you go down here, white space. So it doesn't care about white space. It's going to call white space just a white space. And then you have text is select, type is select. This line 2, column 1. So like this, it's breaking up the whole statement into different elements, trying to find out whether or not it's a reserved word, and then the line and column number it is located. So star is not a reserved word. This is not a reserved word. And then you go down, from is a reserved word and such. So it can do this for the entire text, the whole stored procedure, or whatever else that you want to provide. And how is this useful? Why do you need tokens? Tokens are useful when you want to search something in comments. Like typically, you intentionally want to search for something in a comment, like if somebody's name, if this person A made the change, you want to look for that in a comment. That's when you need to put tokens to use. Also, you have sometimes you have rules that the tree cannot find automatically. Like for example, you may have a rule that all your reserved words have to be a certain case. So the only way you can find out whether or not something is a reserved word is by using a token. So if you have an anti-pattern like that, then you find tokens useful. So this is the kind of purpose for which it is intended. Okay, so we saw tokens. And why is it needed? Then the abstract syntax tree. Then using ScriptDOM as a formatter. Okay, I can demo this too. Okay, formatter. Okay, formatting is essentially, it's somewhat a tricky issue. Most people have their own issues, their own rules around how you want to format T-SQL code. So I'm going to see, how do I get to my Explorer? Okay, here we go. All right, so formatted procedure. I just created a procedure where I have a bunch of code like this. So it's not aligned, it's somewhat annoying to look at, and I need this formatted. So what I'm going to do is to use ScriptDOM to try and do the same thing. There are a number of free formatting tools available, so it's not that you're stuck with this thing, but it's just part of the number of things it can do. So I just want to show it to you. Okay, so unformat proc, and I'm saying, go and format it. So what I'm doing here is what I used the generate script class, which is part of what I showed. And so I'm asking it to go. There are a bunch of rules you can set about formatting depending on your preferences. Generally, these are not difficult at all to understand. Usual rules, you want to see whether you want a semicolon after each statement, you want to align the bodies, align column definition fields, all this sort of stuff. Keyword casing is one, uppercase, lowercase, Pascal case, whatever. So you can set your preferences as you wish there, and then you can provide it with the file. And here I'm using a file. I'm using that unformatted procedure I told you, and I'm asking it to go create a better one for me. So this is what it has done. Let's go and take a look at that.
So for that, Mala, would you like edit that PowerShell code for your individual preferences?
Yeah. So this is my what I had before. This is what I had after. I had some stuff in lowercase, so it has fixed that for me, and it has done, moved all my code out, cleaned this up neatly, just moved this thing to the right, not aligned with the insert, and this sort of stuff from here. All of this is aligned. So not bad. There are some disadvantages to it though. The main disadvantages are that this thing removes the comments in the stored procedure. And I'm not a fan of that. And I have an item open for Microsoft to go and fix it. So if anyone's interested and you think this is going to be useful, I have the GitHub link on the presentation, which I will be sending to Krista after we're done. You can go and upload this thing. It's been sitting there for about more than 2 years now, but they have to fix it because nobody wants their comments gone when you format it. It formats and gets the alignment and everything right, but you don't want your comments stripped away from it. And so that is something that they essentially have to fix. Aside from that, if you have some old legacy code that you don't care about and you just want it to be made readable, then yeah, this is a fine way to do it, and it'll do it like, in split seconds. It does a neat job. It's not going to mess with anything else other than your comments. So okay, we saw how we use it as a formatter. The next thing that is about visitor class. What is a visitor class? So essentially what we saw is that if you have to use this thing to find something, like I was trying to find the name of the column and things like that, I have to walk the tree. I have to go level by level down the tree that it has constructed. This is similar to somebody, if you were to find it manually, somewhat like someone picking apples from a tree by climbing it. There are chances that you're going to miss a lot of apples. It's going to be labor intensive and difficult. If you use walking the tree, it's going to be a little bit more efficient compared to picking it manually. It's going to be like that tool that someone is using, but it is still labor intensive because the tree can be pretty big depending on how big your code is. You may miss certain branches and not find certain things. So this is why, this sort of tool is still labor intensive, even though it's automated. This is why they came up with something called a visitor class. A visitor class essentially is more like that thing, like that machine, like it's going to get you all the apples with one shake. So when you define this visitor class, let's say I want to find something called the select star statement. If I create instantiate a visitor class like this, what it's going to do is to go into your code and grab all the instances of your select star for you. And I show how this works in instant. So it's not going to be difficult. You don't have to write hundreds of lines of code to walk the tree to find it. And it's not going to miss anything. It's going to find every instance for you very quickly and very efficiently. So this is the advantage. And the visitor class essentially is derived from the base class that is called T-SQL fragment visitor. And it has a method to use. So the method essentially defines what you have to do when you encounter let's say select star or whatever is the anti-pattern you're trying to find. You code what you want it to do. You typically, most of the time, what you code is some sort of an alert where it tells you, hey, I found this. Okay, so tell me what to do with it. Right here is what on line 3, column 10, you have a select star. Okay, this is what you need to know about your code as the developer to go fix it. So that's what we're going to see the visitor class now, and how really efficient it is for you to find your anti-patterns. So I'll demonstrate how the code looks and then how it works. So if your anti-pattern is a select star, what you do is to create a class called, you can name it what you like. I call it visitor select star, and the visitor class it's going to use is T-SQL concrete fragment visitor, and within that you say it is a select star expression. And then you say, once you find my select star, just tell me that you found it. And all you need is this much of code. This is just 4 lines of code you need to find all the select stars in your code. So you say you instantiate one instance of that class, and then you pass to it the output of that parsed object. What this is essentially is the output of that parsed object, which is your syntax tree, your abstract syntax tree. So you ask this tree, invoke this method to, and pass with it that will select star object, and it will find it for you. So let's see how this works. So find select star. There are some select stars in this code that I'm going to be passing to it. I just have a wrapper around it so that this is the code I'm passing. There is one select star here, one here, one here. You can see there are multiple. So I want it to find all of this for me. And this is what I do. You say hello. There it is. So it found it at line number, column number, and it told you all these select stars in that statement. So pretty cool with that. Now let's see another example. Let's go find a nolock hint. So this is a fairly common anti-pattern that people have, and for this what you need to use is a table hint. This is the name of the visitor class that you use, and there is some coding involved. Some of these visitor classes are generic in nature, so when you say table hint, it's going to find any hint, any table hint that you have. You want it specifically to go look for nolock, so you look for a hint kind equal to nolock, and if it finds that, you say nolock hint found at blah blah blah. So just again 4 lines of code, and some people use read and uncommitted for nolock. So you want a visitor class to find that too. So you say transaction isolation level statement, and then it goes within that. You say fragment level is read uncommitted. Then you say, okay, this person still has a nolock, just not in the statement. It's an isolation level. So because you're using 2 visitor classes, you need 2 instances. First one is the table hint. Next one is whatever that isolation level that you find. So code for these 2, and then you do that. And then you go here. So it found everything. It found all the nolocks, and it found the isolation level too. Then let's look at 4-part name. 4-part name could be an anti-pattern depending on the environment you are in. Nobody likes linked servers, and we know we have other ways around it these days. So if you have some old code where people have used a lot of linked servers, you can find that with a 4-part name. So if I go and look here, I might have some 4-part names in this code, and I wanted to find it. Let's see what it finds. So line 43, if I go and look on line 43, there I have a linked server reference. So that's what it found. And then find reserved words that are not uppercase. Okay, this is a slightly different type of coding. This is what I said, when I demonstrated tokens. This is not using the visitor class because the visitor classes don't know if a reserved word is uppercase or not, and you have to take each token and that is keyword thing that we saw. You check for that, and then you see what the case is, whether that case is upper or lower, and you say, this is what I wanted to find. So that's how it does the reserved words thing. It doesn't use any visitor classes. So it does that. So it's saying it found one on line 60. Line 60, I have a from that's in lowercase. And then on line 64, I have an insert that's in lowercase. So that's what it found with finding the reserved words. Okay. So those are some examples of the way it works to find anti-patterns. Anybody have any questions?
We haven't had any come in, except for the one that I asked.
All right. No, I ran too fast. Okay, using ScriptDOM to fix what it finds. So typically, I'm not a huge fan of this. because mainly because in stored procedures, it does the same thing that I showed you about, that it scripts out the comments. But not all of your code is stored procedures. If you have indexes, if you have tables, the nicest thing is that with indexes, if you have somebody who's missed a setting, let's say you have data compression turned on with all your indexes. There are a couple of developers who have habitually, they tend to forget adding the data compression. Now, once that thing goes live, it's really a big pain for you to go and find it and then fix it afterwards. It's going to cause some outages and some downtime, and because it's going to take time to rebuild and all of that. You don't want that. It's undesirable. You want to find this before that code goes on production. So what ScriptDOM can do is to find it and fix it for you. Things like table scripts are totally benign. It's not going to remove anything from that. There are typically no comments to worry about, so you can absolutely use it for things like that. And again, if those comments are not such a big deal for you, you can also use it to remove nolocks from the code. So I show you how you can do any of this. So let's look at find and fix the nolock hint with setting first. What I'm doing essentially is the same thing, parsing the code and then regenerating it without the hint. So let me look at the part where if you have a read uncommitted, what it's going to do is to change it to the default read committed. It can't remove that line entirely. It cannot remove entire lines from code. It can only remove certain things. So this entire line it cannot remove. But if you have the nolock, you can code for it to say table hints remove whatever hint you find. So I have some code here. So proc with nolock is with textpad. I have some nolock. I have this also, because it's just a demo, I have both in this code. I have set to transaction ISO level, and I also want to a bunch of nolocks here. There's one here, all of this. So I wanted to remove all this from my code. I go here and I say create a proc without an output file. Then I go back here and I say compile this. So it's changed that to committed, and all those nolocks are gone. So if you have a need to do this, this is the simplest, easiest automated way to do it. Then the next one is the index setting that I said. So you have an index that someone has created and you want a data compression setting there that is missing. So this is the index the person wants to create. They don't have a compression setting there. And you don't want this to go live, so you want that fixed. And what you can do is the same thing. The generator is the same generator that you use to format. And then you say, if the index setting that is missing is data compression, then you try to add a new option here. Add this option. There is some syntax and some basic PowerShell related stuff that is involved with doing it, but it's not that hard. It's just a short amount of code. And then you regenerate the whole thing and it's going to create an index with that thing automatically added for you. So let's go and look. Go look. Data compression equal to page. Okay. So, go down. Okay, we saw how we can use it to fix what it finds. And then the pros and cons of fixing. This is important to understand.
Mala, we have a question.
Yeah.
So Claudio asks, can we create our own rules? Example, I want to find a long in a where on the where clause. Will it work with similar with finding a scalar function?
Yes, absolutely. You can find anything you want. It's just you use different classes for that and then work with what you want to find. Yes, very possible. I may not have time to show you exactly how you can do it, but from what he's saying, it's in a where clause, right? So you essentially you find the where clause first, and then you walk through whatever that where clause is to find specifically what you need for it. The visitor class you have to use is where statement. So it will find the where statement for you, and from there you have to walk the tree to find what you want to find in the where state. Does that make sense?
Yep.
Okay. So I don't have time, unfortunately, to demo something like that because it's a bit of coding. But
Understandable.
I can show you if you like. I can show you from that. Not this. Where is that select? Okay, parsing select is the one. Okay. So it does this. Query expression. Okay. Past objects. Dot. Dot statement 0 dot query expression. Dot query expression dot where clause. Oh, found the where clause for you. That's all. In this case, your where clause is a like predicate, right? So if I want to change this to where p dot search name one, let's say this, rid of this. So it's going to give you that in predicate. Okay, and then dot predicate. Dot, one second. Search condition dot, sorry, search condition. I forgot the search condition. overthink. Dot search condition dot in predicate. So essentially, yeah, this is how it is to some. You have to go level by level, and once you find the in predicate, then you tell it what to do based on the fact that it's an in condition. Does that make sense?
Yep.
Okay. I try to see if I can come back to it and dig more if I finish the presentation. I don't want to. Few more slides to go. Okay.
Claudio said he got the main idea, so you're fine.
All right. So the scientific method, really short and efficient code. You don't have to write big code to find it. Some of the cons with fixing are that it reformats your code and then it removes comments, like I said. The fix may take, depending on what is the fix you want to do, it may take some effort to figure out how you want to do it. But most of the things, most anti-patterns are automatically fixable. The pros and cons of the tool in general is that, again, it's an authentic method. It's easy to deploy and maintain. It's backward compatible. You can work it with any version of SQL Server. It's asynchronous. It doesn't connect to any SQL Server while it's running, but you get to define and make your own rules and such. Some of the cons are that the memory footprint can be very large, especially with huge scripts. Some people tend to script out their whole entire database into one script and such. Crazy stuff like that. If you do, the footprint is approximately 2 gigabytes of address space for a 15 megabyte. A 15 megabyte file is a huge file. So if you want to do something like crazy like that, then your memory footprint can be pretty large if you're going to use it. The parts are single threaded. Most of this kind of tools that Microsoft makes happen to be single threaded. So you may have to work your own creative ways around making it multi-threaded if that's your priority. By default, it is single threaded. And it needs some amount of PowerShell and .NET programming language. There is no way around that. Although what you need is not a lot, you need a little bit of understanding of object-oriented programming. Without that, it can be pretty hard to parse the tree and to get it to do what you want to do. Nuanced situations, like if you have, let's say, a nolock embedded in a derived table in something, or you have multiple levels of views and you have something there that you want to find, that kind of stuff. Those situations can take some amount of programming effort. They're not terribly hard, but they will take some amount of thinking and some effort. And basically, most of it goes down to how well you understand object-oriented programming. If you know that what calls what and how these things are nested, then it's pretty easy. And it takes a little while to get to that understanding. Again, like I said, the formatter needs to retain comments. I don't know when Microsoft wants to fix that, but without that, to me, it's not of much use to use it for formatting. These are some references. There is not a lot of talks out there, but there are a few. Most of these are pretty old, but they're still worth watching because conceptually they are the same. So if you want to watch it, I have some here, and that's it. Thank you.
That was awesome. And thank you for that great point at the beginning where you talked about, some anti-patterns are okay when it's knowingly in your environment, because I think that was a pretty important thing. But this was awesome. Thank you. What a great thing for data professionals to add to their toolbox.
Thank you.
So as Mala mentioned, she will send the slides and we will add a link for those. Do we have any additional questions from the group? Nope. Okay. So I probably have a few questions as usual.
Okay.
since we have just a couple of minutes. So this, you mentioned that this comes installed with SQL Server, and that's really awesome. Would, if SQL came out with a patch, might that include some updates to this as well?
Mm-hmm.
Yeah, okay.
Very possible.
And then go ahead.
I have not seen any patch break it so far. We've been using it for three versions. We started using it with 2017 and we are now on to 2022. I have not seen any patch break it so far. So they're pretty good with that.
And then Claudio also asked, and I know the answer, but I'll let you answer. Are these scripts publicly available?
Yeah, it's on my GitHub link, and that's part of the presentation deck.
And so your demo that you did, it was in VS Code. Do you need anything special in Visual Studio to add to it, or just a regular install that you mentioned at the beginning?
Regular install, just a PowerShell install.
Okay. And then in your experience, what's the most common anti-patterns you see that you're using with ScriptDOM?
Select star, nolock. Very common. Nolock, especially, extremely common. Things that are peculiar to my environment that I see too, I see a lot of temp tables without named indexes, which again, that is a problem if you're using query store. So I think everybody should be using query store, but if you are using it, and if you still have developers who want to write temp tables and without naming their indexes, then it's going to be difficult. So that is an anti-pattern that I catch all the time, and my developers don't like it, but I catch it all the time.
So you use that in tangent with Query Store?
Yeah.
Excellent. So you kind of know live what they're doing.
Yeah.
Even if it's not necessarily in their, in their stored procedure or whatever, you know what's coming in, what they may be doing to lock everything up. Awesome. Yeah. So that's all the questions that I have. Are there any additional questions? Okay, then the only thing else that I will say is go upvote Mala's GitHub request to preserve comments within that application. So we can keep that. I know that's pretty important to a lot of people. So great call out for that, and glad that your link's in there for that. So go and upvote it, everybody. So that'll help get that introduced in there. And thank you so much for a wonderful session. We really appreciate you taking your time out of your day to come speak for our group. Thank you so much.
Thank you. Have a good evening, everyone.
You as well. Thanks, everybody.
Bye.
Oh, thank you. Bye.